Okay, so for kind of our other questions using inequalities, kind of taken away from the context and like word problems and stuff like that, we're going to be taking a look at just a couple of examples that we're going to represent in other ways. So maybe if we're given graphically, how can we represent it algebraically, and kind of vice versa from that. So let's kind of start on our first question here. So express the inequality shown on the number line algebraically. So what we're going to need here is a couple things. First off, we're going to need to figure out which way is the arrow pointing. Is it pointing towards larger numbers or smaller numbers? And where's our boundary condition? And what type of boundary point is it? Is it like a closed or is it open? So let's kind of put all these things together. First off, I just want to make sure that you guys knew that when you see this red arrow here, that's representing the inequality. So really, even though it's not as bolded, this is kind of the way that the arrow is going. And it looks like there's an open dot here. So let's kind of put those things together. We have an open point. And it looks like this point is at, if we start counting from negative 130 and then working our way down into lesser numbers. Remember, we're in the negative land here, so we kind of have to think a little differently or a little backwards. This would be, let's see, 1, 2, 3, 4, 5. There's kind of 5 separate areas between these two numbers. And there's 10 separations between them, or 10 numbered separation between them. So that means that each one of these is representing 2. So our point here would be negative 132, negative 134, negative 136, negative 138, and then negative 140. We have an open point. It's at negative 136, and our arrow, it's pointing to, or it points to larger numbers. And we know this because since we're dealing with negative numbers, all of the numbers to the right of our boundary point, our open dot, they're all going to be considered larger than it, because that's how we make our number lines. Just got to think of it a little differently when we're in negative. So I'm just going to I'll use x for this question. X has to be greater than negative 136. It's not going to be equal to, because we're not using a closed point. It's greater than negative 136 because all of the numbers that this arrow points to are larger than negative 136. Think of a number like way, way over here. This is kind of like positive 20 way over here, right? If we were looking at the number line, this would be positive 20, which would be larger than our number over here if we were to extend it all over. So just make sure that we can think about negatives kind of in that way. And that would be it. Let's take a look at B. Represent the inequality n is less than negative 12 on a number line. Let's pop a number line down. Let's put our point of interest on negative 12. I'm going to put it right in the middle. I'm going to do 1, 2 numbers that are above negative 12. I'm going to go up by 1 each time. So this is going to be negative 10. 1, 2, this is going to be negative 14. I know this is negative 10 over here because it has to be larger than negative 12 because, again, if it's to the right of it, then it has to be larger. That's how number lines work. And then, of course, our number negative 14 must be less than negative 12 because it's to the left of it. And again, that's kind of how our number line works. We're going to use an open dot because we see that our inequality is a strict less than sign. And we're going to point our arrow towards numbers that are less than negative 12. And that's kind of B for us. So hopefully we kind of are all good with this kind of stuff. Again, we're dealing with negatives, so it's a little bit harder, but as long as we keep it in that, hey, numbers to the right are larger, numbers to the left are smaller, and then you're just going to kind of piece it together from there, it should be okay. Let me know if you guys are having problems with that, and we could do some more examples, but it should be okay, I'm thinking. Let's go on to C. C is to write an inequality for the values shown on the number line. So in our number line here, there's a couple things that we want to make sure that we can point out. First off, really important that we can see this because our two numbers that we're between are 0 and 1. Now, you can think of it here as, okay, which number are you closer to? But what I would rather get you to think about is which number is smaller? Is 0 smaller or is 1 smaller? And remember, we're in the positive region. So kind of ask yourself, which one is smaller? And since 0 is smaller than 1, kind of our number is not going to have a 1 in front of it, if that kind of makes sense. I know this is a little bit confusing with the 0 and the 1, but you got to make sure that you're always choosing the smaller number first to build your number. Because again, when we're looking at numbers, we always go from small to big, just like our number lines do. So from this one, let's kind of count out a little bit about how many divisions we see or how many sections we see between these two numbers. And you should be able to see that there's 1, 2, 3, 4 separate divisions between these two numbers. And our number line is covering up one complete section from the smaller number. So let's kind of put that all together. We know that there's 4 equal sections between the two. 0 is my smallest number or my least number between the two. And I'm covering up one division between this number and that number, so 0 and 1. Technically here, if you really wanted to, right, we could be thinking about this as there would be sort of like this imaginary little 0 in front of this fraction. I wouldn't really recommend you writing this because we would never write mixed fractions with a 0 as the number, but this is really saying this is 0.25. And when I'm saying that we're choosing 0 as our smaller number to begin our number with, that's really what I mean. This is the number that we're going to begin with. We would never say that this is 1.25 and choose the larger number. That just wouldn't make any sense. We have to choose the smaller number to do that because, again, we're reading our number line from least to greatest, and we're in the positive numbers here. So we have our boundary condition. It's 0.25. It is a closed dot as well. So I'm just going to make my value x has to be less than or equal to. I'm going to use a fraction. Feel free to put 0.25. That's okay too. And of course, it's less than because our arrow is pointing to values that are lower than 1/4. Now, there is another section, part of this one, where it says, hey, describe a real-life scenario that this inequality might represent. We don't really have to go a bit into that, but I'll tell you a little bit about how to think about these so that you can, guide your thinking along the right path. Try to use things that have negatives in them, right? A lot of people want to use like time, or a lot of people want to use money, but that doesn't really make a lot of sense when this arrow is pointing into the negatives. So maybe something else would be a good idea here. Maybe something like temperature could represent it. Maybe something like distance could represent it from a certain point. You can go negative distance from it, and that's just working your way back from it. So things that would have negative in it would be appropriate for this one. There's a lot of different answers, but don't try to pigeonhole yourself into thinking about money or time, because then, or like age, let's say, because that doesn't really make too much sense if you're going into the negatives, which this definitely would, because that would be smaller than or less than 1/4. All right, we're on our last question here. D, show the possible values of x on a number line if -7 is greater than or equal to x. And what is a different way to express this algebraically? Sure. So we're going to go on a number line. It only is telling us the point of interest. It's saying our boundary point is -7. I'm going to put some values over here that are above -7. I'm going to put some values over here that are below -7. And we know that it is a greater than or equal to sign, which means we're going to use a closed dot. Now think about this. -7 is greater than or equal to some unknown number. Well, if -7 has to be greater than a number, then all of these numbers have to be less than 7. This would represent -7 has to be greater than or equal to x. Now this is kind of awkward. I don't like representing inequalities like this because it just kind of is inherently confusing. So instead of writing it this way, I'm going to write it in a different way. I'm going to write this inequality a little bit differently, algebraically of course, but a little bit differently, and I'm going to start with x and say that x has to be less than or equal to -7. Take a look at the inequality sign. It still is opening to -7, right? It still opens to -7. It still opens to -7. We have to make sure that that still stays the same when we rewrite it in this way. Now it's really clear that x has to be less than or equal to -7, as indicated by my diagram, but we also could say it as -7 is greater than or equal to x.